So it says sending data now. Let's see. All right, we should be streaming now. If somebody is on chat, please let us know if you can hear us.
No, I think that stream went off because it shows 1 second stream, and that's it. So it streamed 57 seconds ago, and it's just a 1 second stream.
Okay.
So means it like it went live for a second and then it went away. I don't know what's happening.
Check. Somebody from Build Safe says yes, it's live. Check. Yeah, I think we are live.
Okay.
Are you still having trouble accessing the stream?
Yeah, I don't know which link it is streaming from, but yes, now I think it's live. Yeah, we have 4 people
Yeah.
viewing the stream. Yep,
Okay.
works.
But the webinar page on OpenSSF points to a different stream link.
Yeah, I think it created a new stream.
Okay. Let me see.
Yeah, the link is different. So I think that link got expired or stuff. So I'm sharing the link wherever.
Yeah, let's maybe take a couple of minutes to update social media. Hello, folks. I really apologize if you're viewing this. There's some snafu with the YouTube streaming link. People are reporting that the original stream is not working, so we're just taking a couple of minutes to update things. So I've updated the page. It should now have the link to the right stream.
Cool.
So after 10 minutes of debugging AV issues, which is not uncommon for a live stream, I think we can get things back on track. Um, Hello, everyone. I was at the beginning of the introduction. I said that it's a real pleasure having Saiyam on the stream today. Very recently, I heard him speak about software supply chain security and things like that. So I wanted him to come and be a part of the stream and have him as a guest on the show. And one of the things that we love to discuss on the show are OpenSSF projects and the whole notion of how to keep open source code bases safe, and not just in terms of writing code that's safe, but there's obviously a lot of things that can go wrong between the time you write code and between the time you make it go live on production. And so I think the world is a testament to how unsafe this can be, and there's a lot of work going on between the time that you need to write and push code out to the point that you publish it. And that's been a common sort of thread among all of the speakers who've come here and who've spent time in educating people and things like that. And so thanks, Sayam, for taking the time. Do you want to maybe quickly introduce yourself before we begin?
Yeah, I mean, my slide has that. So if you can pull up the slides,
I sure can.
yeah, I can run through it. Yeah, just a second. Yes. So, yeah, Ram already introduced me. So, I'm currently working as principal developer advocate at Loft Labs, founder of Kubesimplify, Build Safe, and KSCTL. One of the tools I'll be discussing today is Build Safe. And obviously, the general, like Ram mentioned, the OpenSSF projects, how we are kind of using it, and what's what's important, how you will be able to kind of use that, and how OpenSSF is helping. Previously worked at Civo, Walmart, Oracle, HP, and also Cubestronaut. These are my socials if you just want to connect with me. So yeah, before actually diving into just elaborating the point what Ram just mentioned on the software delivery cycle, like from writing the code to kind of shipping it, till the end, there are a lot of pieces that are involved. So let's take a scenario of, since the cloud native era is always on the boom, and Kubernetes is something which has become a de facto standard. So modern day application, people are building it, writing Docker files, and adding dependencies, bunch of dependencies on the Docker files, and then deploying that onto a Kubernetes cluster. So basically, this is how we ship this software in the fancy CI/CD ecosystem. So write it up, package it, add external dependencies, libraries, OS packages needed to create that particular artifact, push that to a registry, and deploy to Kubernetes. Right? Good flow, working well. What could go wrong? So the thing is, with more tools, we have come to more threads. So more tools means more threads. So basically, we started off with monolith applications, and now we have microservices. The microservices running as containers in the whole container orchestration system. So we kept on adding layers, more and more layers. So we use cloud, that is one layer. Then we have the infrastructure, that's layer. Then we install Kubernetes, that's itself is a beast system which has its own set of components, own set of attack vectors. And this is something which uh, you know which means like more tools leads to kind of more threats. And you can see the one that we saw above, right? The CI/CD cycle, the small CI/CD cycle, the modern one. At every stage, starting from writing the code till deploying the code, there are the possible ways that things can go wrong. So, and these are very famous attacks. Like these are not made up things. These are actual attacks that have happened and caused millions and millions of dollars to be fixed, and issues, and then compromised repositories, compromised data, secret data leak, all that stuff which has happened. So executils, for example, at the stage of writing the code, see, we have to kind of change our mindset to zero trust. The reason for that is because anybody can inject anything, and this particular thing was very, very clever manifested kind of injecting the bad code over the years, doing that and building the trust and then doing it. So it was very interesting, how this was being done. Coming to the compromised repo, so you might have heard or seen a lot of secrets being exposed in a lot of repositories. So repos are compromised, build system itself gets compromised. So you create an artifact, but the build system that you are creating that artifact on, the build that is being run on, is compromised. Solar wind attack was one of the famous one in this particular area. Compromised dependency, very famous log4j attack. You use knowingly, unknowingly, famous libraries out there, and then something goes wrong in one or the other dependency, and your software also is, on the risk of being compromised. Artifact tampering and deploying the compromised code. So these are some of the things. That's why we are kind of talking about it. That's why it is important. Some more CVE attacks, Urgent 11, that was into the real time operating system called VxWorks. So there were 11 vulnerabilities found in that particular OS, and that particular OS was being used in MRI machines, patient monitors, F-22s, like all the mission critical applications. And still, I believe there are like more than 60-70% unpatched devices, because it's not easy. I mean, they released a patch, the CVE, specifically for the versions, I think 5.6, something like that. And this is, sorry, that was executils, but yeah, this one was a bit before that. But yeah, very big one, log4j, Java logging library. PyPy attack, typo squatting attack, where the library itself is malformed, and it looks like it's not malformed, and people end up using that. Executils, very famous one. This flaw was sneaked into the software by kind of doing the trick code that was very hard to identify and spot. So it messes up with the SSHD. So yeah, these are the famous attacks. That's why we are talking about supply chain security. That's why it is important to care what you are shipping, what you are using. And that brings to one of the very famous and the very common problem, is the metadata problem. What does that mean? So take an example of what we eat in day-to-day ecosystem, like day-to-day what we eat. So we consume products, like we go to the supermarket, we buy the products, everything is fine. But how the whole shipping cycle works is farmers are growing crops. These crops are then going to factories. Factories have big machines. They are preparing it, packaging it. Then it goes to the local shops. The whole supply chain, the bigger supply chain, local shops, and then distribution and storage. They store it, and then we kind of go there and consume it. So there, now the thing is, when we see the end packet, or a packet of biscuit, or whatever that is, whatever we consume is having a lot of information written on the backside, which includes the ingredients, the expiry date. Now things can go wrong at every stage. Like you can see, in the crops, the farmers might use excessive fertilizers. Things can go wrong over there. So the checks have to be made at that level. Factory can use very dirty machines, or not the right equipments for packaging and stuff. It has to be rectified there. Local shops can sell expiry goods and may sell all these things, so that has to be taken care at that particular point. Still has a lot that they can do. I mean, obviously they don't know the type of crop and stuff like that, but they still know that whether palm oil was used or not. They still know the expiry date, which is there. They can read that. They can read the ingredients. So at least they have the metadata, what all ingredients are there. At least they have some dates. At least they know the manufacturer, like from which particular facility this particular packaging is being manufactured from. So this particular thing is what most softwares misses out there. Like when we are using, for example, when you are using a Docker image out there, you probably don't know what is there inside, what is the metadata of that, who is the owner of that, when it was built, when it was shipped, is it under a company label, is it approved, all that stuff is missing from the software. So you can see, farmers can be like the software producers, then your factory can be the whole CI/CD pipelines, then local shops can be those registries, and you are the end users, can be the developers. So this is the metadata problem which is there. Second is the Docker file. Most of the things, since we are talking about the microservices architecture, so we are using the Docker files over here. And what we are doing is we are going and picking up anything from the internet. Let's take a more complex Docker file to showcase it more. So you can see that the run apt get update and apt get install is just installing anything without any version pinning, and getting anything from anywhere. And the curl commands specifically gives a huge risk of what is being downloaded from that particular link and being installed. So this is a nightmare for security teams. This is a very big nightmare for security teams, because imagine you are an enterprise. An enterprise is having hundreds and hundreds of projects, hundreds and hundreds of teams, and then thousands and thousands of developers. Every team writing their own, for their own project, writing their own Docker file, doing whatever they want to do from the internet, poses a big threat to the company. And then the security team is obviously stressed, because how can they run through all the things and scan those CVEs, whether this particular dependency, whether this particular package is not vulnerable or not. um, Even if they kind of create that, you have to use this, what if someone changes something? Like there is no declarative thing that is being done from this particular side. Although we have Docker file, everything is there, but shouldn't it be shifted? Like, can we do something? Can we change the whole game? And when we are building this file, can we use the base images as 0cv images? For example, here the node 10 must be having a lot of vulnerabilities. Can we use those 0cv images? Can we use version pinning? So some standards, some practices that can be done across, so that there is less stress on the security teams and it's more streamlined and stuff like that.
I mean, what you're showing is a little scary to me, because this is how everybody writes their Docker files, and this is how most people I know are shipping. So I am a little scared when you say everything about this is, you know, waiting for just something to happen.
Exactly, exactly. So we are living in a scenario where people think that uh, this particular file is fine. I am not a big company. My startup is there. Who will hack me? So when there is an attack, that attack goes like, you don't know how this attack can spread. It's like a virus. It spreads like a virus. And as soon as the attacks gets some level of visibility on Twitter or socials, it gets boomed. Now you have to change at night, 2 a.m., 3 a.m. in the morning, and have to fix it. That is the nightmare. Spend dollars on that, then security audits being done again to rerun that. So there's a lot of things, and Ram exactly said the right words. These are standard Docker files that people use. What's wrong with it? Yes, there is a lot of things that is wrong with it. So we should not use what is shown on the screen. It is exactly similar to this. So you found a USB stick on the ground and you are just plugging it onto your system. That's what you are exactly doing when you are doing a Docker pull for any software that you feel, oh wow, this particular thing solves my problem. Let me use it without investigating anything, without knowing anything about that particular image. We are just doing npm install, Docker pull, and what not. this is the dependency hell that we have to come out from. And this is where I think the OpenSSF organizations like OpenSSF and their projects play a very, very crucial role in educating, in setting up the whole foundation, setting up the whole ecosystem, setting up the project, setting up the processes, and making sure that it is streamlined. And it is not a one-man game, a one-person game. It is actually the whole shift. Like the DevOps is the cultural shift, supply chain security is also a cultural shift, and people should know what is happening and they should be educated on stuff. And that's why this particular webinar is for as well.
Yeah, absolutely. And I think the other workflow that I can think of is, I got stuck at a point. I was googling for my error messages, and then there was an answer on Stack Overflow asking me to modify my Docker file like this, which is 6 years old. But I just copy pasted it, and my Docker file now works, and my build passed, so I'm golden. That's the other thing that scares me when I speak to a lot of developers. And um, it ends up looking like what you showed, and people don't know what they're putting into their builds, and um,
Exactly.
has a lot of potential for things to go wrong. But yeah, I'll let you continue.
Exactly. So the metadata that we were talking about, the farmer's analogy, there is a thing in the software ecosystem which is the software metadata, which is called SBOM, software bills of material. It is the actual software manifest that has dependencies, library information, licenses. Even there are the government orders like the White House order, EU order, that mandates, whenever things are being used for government, it has to have SBOMs for the software. And this will definitely in coming years, one or two, will become even more stricter, even for any organization out there, not only the government ones. So SBOM has a lot of benefits. With SBOM, there comes a lot of things that can be, like these benefits are good, but there is something which is called SBOM quality. So the even with the SBOMs, the quality has to be top notch so that it actually gives meaningful information about the software. And it's just not, because within SBOM also there are different formats, and some people adding little bit of detail, also claiming it to be a SBOM also is not a good thing. So that's why there are projects like SBOM QS, which is for the quality check. Good projects out there that works. And then we have, yeah, these are the formats that I was talking about, like Cyclone DS and SPDX. You can think of it as like, you have you are viewing an image. Now this is where one of the very good projects from the OpenSSF comes in. But you have an image. It can be PNG, it can be SVG, it can be JPEG, JPG, but it's an image, right? Similar to that, there is a SBOM, and there are different formats of SBOM that have, you know coming from different, like a different project in different foundation, and you know things like that. um, SLSA, again, it's part of the OpenSSF. SLSA is pretty cool. It is, as you can see, it is the industry standard set of incrementally adoptable guidelines for the supply chain security, and established by the industry consensus. And the specification is set by SLSA, used for both software producers and consumers. So you can see there are, and the focus is now more on the build side. So now it is build L0, L1, L2, L3. So L1 establishes, sets a foundational stage of tracking and debugging and verifying the software builds. Progressing to L2, it strengthens the security measures, making it more difficult for the attackers to tamper the build. And then level 3 provides more robust protection against the tampering of the unauthorized access and stuff like that. So I think this particular thing is really good in the software ecosystem. And with this, I would like to introduce a tool, also how we are kind of using some of the projects from OpenSSF. One of them is SLSA, another one is Protobomb. So build safe, entering into build safe, the whole idea is to obviously enhance the supply chain security, make it better. It's a CLI tool, open source CLI tool, to build the packages with zero or less CVEs, and zero CVE base images, uses Nix under the hood, building the tamper-proof build. So basically, tamper-proof builds are bit by bit reproducibility, like artifact that is built on any build system should be the same artifact, and it should be cryptographically verifiable. And this exactly was the wind's attack. And because what happens is your GitHub runner can be compromised, your CI systems can be compromised, and the tamper proof builds should be important. So SolarWind attack, where their build system was compromised, and to rectify that they created multiple systems, and for each build their build was ran, and then artifacts was checked cryptographically to make sure that the CI is not compromised. Then high quality attestations, like it's, see, when you are building the software and when you have that build information, you have the better quality of the metadata versus when you have built the software, like when you have the artifact. Because after having the artifact, you still generate SBOMs, like there are tools to generate the SBOMs, but the quality is a little less than generating it at the build stage. When you add at the build stage, you will add more information about the build systems, what is being used, from where it is being built, so all that information also gets in. So I think, and also it would be very good to have a declarative way at the build stage to have these added. So this is what BuildSafe does, providing high quality attestations. Shifting security left, which is also one of the core features. You can actually search for the packages out there. It uses Nix under the hood, by the way, but you don't need to know Nix. It's completely fine. But what it does is you can search for a package, add it, whatever you need for your development environment, and check if that particular package is having a CVE or not, so that you, when building your software, can use a OS package or a dependency that is CVE free. And this is what will make your systems more secure and robust.
So just to interject you there, Sayam, we're talking about zero CVEs, which is wonderful to know. Minimal CVE is great as well. In the current workflow of a developer, how do they check for how many CVEs they have? What's a good way to ascertain how good or bad or medium my current builds are, and my current containers are, and current images are?
Yeah, so there are various tools. Very common ones are like people can use Gripe or Privy to scan just the images that they have built, and they will know what the number of critical, high, medium, low vulnerabilities that particular package or particular build that they have done is having. So in the demo, I will also show the Docker file. Like the Docker provides a command for like Docker init, and it generates a basic best practice Docker file according to Docker, because that's what it should provide, right? And even that, if we scan, the base image that they are using is having vulnerabilities. So that's how it is. I mean, it is less, I'm not saying it is more. Chain Guard, on the other hand, is another organization that has been working a lot in providing a lot of like SIG store projects, contributing over there, contributing to OpenSSF, AppCo and Melange to build those images and stuff. uh, but again, the simplicity is not there. It's similar to, like, I would say, LXC and LXD were there for building the containers, but Docker simplified the UX. I mean,
Absolutely.
that went ahead. So that's what we are kind of trying with BuildSafe, to improve the user experience of how easily you can do these things, because people know we have to do this, but the developers are lazy. And when they become lazy and it's not their job, because the security is not their job is to add the functionality, the business logic, and that works. And that time they become lazy. Okay, my business logic works, I don't have to work any further, so I am ready to ship this. But that's not good from the security standpoint. And if that level of ease is provided to them, okay, then it's fine. Okay, if I can easily search for a package, add it, it's zero CV, I'm okay with that. I don't have to do much of a hassle over there.
Cool. I'm sure you're going to show this at some point,
Yes.
but somebody asked a question about, can we get the repo link to build safe?
Yes, I think the Build Safe team and Kubesimplify are online. So if someone is listening and can send a link in the chat, that would be great.
Yeah, I know the buildsafe.dev.
Yeah, buildsafe.dev.
Yeah,
That also points to a website and the repository is there.
cool.
Um, Coming to the S bombs and coming to one of the fancy projects in the OpenSSF ecosystem is Protobomb. So Protobomb is a protocol buffers representation of SBOM data able to ingest document. So just this particular piece is very important. Able to ingest documents in modern SPDX and Cyclone DX versions without loss, and it has accompanying Go library that generates Go library generated from the protocol buffers definition that also implements ingesters in those format. That simply means our build safe CLI uses the open SSF tool protobomb to kind of generate the different format of attestations. So build safe. Other thing in OpenSSF is OpenSSF has a lot of working groups. So just think of it as in Kubernetes you have a lot of working groups. OpenSSF also has a lot of working groups. One of the working groups is working group securing software repo. In that they have defined a lot of principles, like a lot of papers and best practices. One of them is principle for packaging package repository security. What that means is for CLI, like when you are building a CLI, like build safe. So there is a level one. That means CLI should allow installing dependencies that are pinned based on hash and version. So build safe already allows this. Level two is the CLI should warn of the known security vulnerabilities in the dependencies when installing packages. So build safe provides this. And third is the CLI has functionality to produce SBOM. Yes, build safe produce high quality attestations. And the CLI has the functionality where possible automatically remediate known vulnerabilities. So build safe also has an update mechanism, and you can auto update your dependencies, OS dependencies. So the CLI itself, all the features that we are providing is adhering to the OpenSSF working group, which is there, and the principles defined by them. Build safe attestations. So this is like the one that we generate is basically the SLSA. So SLSA has the standard doc. The SLSA that I showed earlier, it has a standard doc called provenance. Now that provenance we are generating along with the Cyclone DX and SPDX. So for example, when we are building the piece of software, what we have used, etc., are mentioned in that particular provenance talk. Now, Cyclone DX and SPDX is having what is there in the software, but not how it is built. That is what I was telling you. At build time, you have more information, and that's what provenance also means. So, SBOM are the ingredients, and provenance is the recipe. You can think of it like that. Um, so you get level 1 SLSA out of the box when you're using build safe. Level 2 and 3 are mostly dependent on the build systems that you're using, because right now it's open source tooling. We don't care where you run it. We just make the tamper proof builds. That's the kind of high level architecture. Like it's declarative, so you get this file which I'll show. And the overall thing is security teams being able to host their own registries where they have defined the packages, done the security checks, and people can use from there. So let's dive into the demo to actually understand more. And yeah, this is the Discord community of build safe that you can join. So the future things that we are working on: CVE, free base images support. The alpha preview is already there for that. Package releases, how you can release packages directly from build safe and automate the OS package patching using the GitHub bot. Just like Dependa bot is there for the libraries and stuff, this one will be for the OS packages. Let's move to the demo without wasting a time. Stop share and let me, okay, different window. Which window is that? Yes, so we have a terminal. I hope you are able to see the, unable to screen share. Interesting. I can do is I can share my whole screen, entire screen. Yeah, I have to be careful. Yeah, I hope now you are able to see the screen. Yes,
There is a terminal window.
perfect. So I won't waste any time in installing and stuff. So I already, because we have less time. But what I'll show is, for example, I'll remove this Docker file first. Uh, BSF. This is the CRI tool, and it has a lot of things. The first thing that you do is, let's say you have a Go project. The first thing that you do is BSF in it. So it reads your repository, like it's which language code it is, and then it auto generates few files. One of the files is called the bsf.hcl file. This is the core file. Now here there are the packages defined, like for the development environment, what are packages that you need. For the runtime environment, what are the packages that you need. Go module is coming already automatic from the go.mod file. And this is the OCI, like when you have to ship the software as an OCI artifact that you can directly use in your Kubernetes manifest. This is what it will be there. So like ttl.sh, ttl is anonymous registry, if anybody doesn't know. Here you define the command that you have to run, entry point if you have to give, environment variables if you have to give, ports that if you have to give, and all the other stuff. So you define everything in this particular block. So this is the key thing, because this makes your build declarative. So this is a declarative way to do this. um, and it uses, like, it automatically generates it, so you don't have to worry most of the things about it. So the next step is BSF build. So this will actually build your application. Now it is using Nix under the hood. So it is actually talking to the Nix repository, getting those packages in, and creating a secure sandbox, like a sandbox for you as well. And you'll be able to, I'll show you how it creates that particular sandbox also. So give it a moment. In the meanwhile, we'll do one thing. So cd build save examples go. Yeah. So what we'll do here is Docker init. So Docker has is a walkthrough. Yeah, we'll do it anyways. So Docker has this command called Docker init. So let's do it for a Go project. And it has created this Docker file. So if you see here, it created a Docker file. Now if I cat this particular Docker file, I can see, I mean, there is a lot of content over there, but we have to focus on but I also have to find it every time, this one. So that's the final image that they're using, which is Alpine latest. Even with this, if I do a gripe Alpine latest, it will be scanning it and like updating the DB and stuff, and then it will scan and show me um, vulnerabilities for this particular image. So let's wait till it shows the vulnerabilities. Hopefully it should have one. Yeah, you can see there are critical vulnerabilities as part of the final base image that your application will be having. Like, it's not even having the dependency that you will be adding afterwards. It's just the base image, and this is provided by Docker, like it's Docker in it, and that's what it is having. Critical vulnerability, you can see, as per reported by Grai. Okay, coming here, our BSF build is complete, so it creates a directory. So it creates a BSF result directory. In the result, it has bin, and it has our application built. It is running on 8080, and if I do a like curl localhost 8080, it should give a proper like HTML file. Obviously, it's a simple app. um, I'm not switching because I don't know which screen will pop up next, because the entire screen is shared. So that's why I did a curl. So it's serving the index.html file. Anyways, the main aim is not the application. The main aim is to see the stuff that it created. So the BSF result also has a thing called attestations into 2.json, which is created. Before we go to this, okay, let's finish this. So in the slides, I told you SBOM information is pretty important. So we have that attestation, and what we can do is BSF has a command called BSF att. Now we can cat this, and we can specify the predicate type. Now we support all three predicate types: cyclone dx, spdx, and provenance. So for example, in provenance, you will see the builder details. That's what I was mentioning, which is not there in, if we do cyclone dx, or if we do the spdx. So all are the formats, different formats. And behind the scenes, protobomb is kind of, being used everywhere for having this, which is one of the OpenSSF projects. Very good one, you should definitely check that out. So this is one thing. Now moving to the next big thing is BSF search. For example, let's say you, as a developer, you need a particular package that you need to deploy. That's what we do, right? That's what we do, the run, and in the Docker file we create, right, those run statements and curl whatever packages that we need. Now here what you can do is, let's say you need a curl package. So we have developed a search functionality called BSF search, and it will search with, all the stuff which is there. Like, you are seeing the CA cert as well, because the maintainers of curl are also the maintainers of CA cert, and that's why you are seeing this, and then all the other things which are there. So if we go to curl, we'll see all the different versions which are there. Now this becomes easy for developer. Next step is, if I select any particular version, I get the CVE information attached to that particular version. And if I can select, like, I want to add it to the development, let's say I add it to the development environment. And here you can select if you want to pin this version, or you want a minor version upgrade, or you want a patch version upgrade. So let's say we do a patch version upgrade. So now if we see in the bsf.hcl file, automatically it should add the 8 curl 811 version which was added. Now if we do a bsf update, so it is updating the package, and we'll see, uh I think we, okay, what was the other one? 811 in the development. Okay, it's doing, we have to do the, let me add 811 and in the development, and allow the minor patch update. And bsf update, and you can see the update, like the curl has been updated to 871. So it automatically updates it. And now this is CVE free. We can also check that. We can search, and we can check that this particular version is CVE free. You can see 0 vulnerabilities found for this particular version. I think as a developer, it becomes very easy to search for packages that you need to add for your application to run. And you can do a BSF develop to actually create a shell with all these development dependencies which are there, and do your development in that particular sandbox. So that is what is happening with the BSF shell. The next thing is, so BSF update, BSF shell, um, BSF, yeah, the OCI thing. So what we can do is, before this BSF dot HCL, H, so you can see we defined OCI dev. So we have defined OCI dev in the declarative section. We have given it a name, like which repository. We have given a command that it has to run, and everything defined in this particular conversation configuration. Now, if we have to generate a particular OCI artifact, we just do BSF OCI dev platform and then load Docker. So this particular thing um, will just build it. For example, this is also building. It takes some time. So this will build an OCI artifact. Now let it build, because what I want to show next is when we scan this particular image, are there any vulnerabilities or not? Because this is something um, we are most concerned about, that our artifact that is created is CVE free or not. Now the next thing that I mentioned in my particular slide that we are working, first is the GitHub bot for auto patching of the OS dependencies. Second thing is the development of um, base images. So what do I mean by that? For example, you do from Ubuntu, like from curl or from Alpine in the Docker file. So you can actually create those images and define the packages. So you can search for packages, define those packages, and then just export it as a OCI artifact. So that is something that is in I think it already works to some extent, but build safe team can comment how much is the progress, or is it ready to be alpha tested, because this is something we are actively kind of working on. This will change the whole game of building zero CVE base images for your Docker file, and then you can use your Docker files to use those base images. Although right now, if you see, I haven't used Docker file at all. So it is just BSF build that was done. And you can see curl, I think curl has a version somewhere, curl hyphen help. I don't know why it's not working. Curl version, then hyphen B or hyphen. Yes. So you can see it's the latest 8.7.1 version. So this is the development shell that was created. So we can exit this and we come back. Coming here, it is still being built, downloading. Yeah, it'll take a little bit time, but yeah, what I was telling was, so you will be able to develop that particular files as well. So with BSF, you are able to check for the attestation, like the attestation options. You can build, obviously, without a Docker file also you can build, but if you have your Docker files, you can still build the 0CV base image, replace that, and keep continuing your workflow. Then develop is the development shell. A Docker file generates a Docker file for the app, and it initializes the project with the Nix Flake files. I haven't told this because I don't think it's relevant, because we are saying here that it has that files, the Flake files and stuff. So if we go to the BSF directory, you can see it has Flake Nix, Flake lock, and default.nix, and go mod to Nix. So these files are auto generated so that you don't have to worry about learning Nix or having a good understanding of Nix. We are using it behind the scenes, and we are also making it easy to use, so that you can just use it without knowing whatever that is. Because in the end, we want to simplify the workflow, and Nix has over 85,000 or 84,000 packages support already there with rich metadata information. That's why the high quality SBOM is being able to generate, and all these things are um, there. Let's see if our build was, yes. So we have our build loaded to the Docker daemon. What we can do is we can do a gripe on this. and you can see no vulnerabilities found. How cool is that? And even if you add missing CPEs, that, oh, I think I copied too much. Even that should give you no vulnerability. So this is build safe. This is out using it. It is using the SLSA, the provenance, adhering to the working group document that I showed, and also the protobomb project. So yes, OpenSSF played always. That's why the organization is there. It has certain projects which are there that we can use, and something that we try to build to simplify the workflow so that people can shifting left the security with an easy way, not in a manner that's a burden. So I think yeah, I'll stop the share now. Yeah, that's pretty much it that I had to share about build safe. Do join the community, do join OpenSSF community. I think there are great conversations going on with respect to everything like S bombs, secure builds, runtime security, hardened security on the hardware side. Like everything is going on in different channels, similar to what CNCF is for the cloud native project. OpenSSF is there for the supply chain project. So everything is available, and you should definitely check it out. Right time to get involved, because the EU orders are even stricter than the US orders for the SBOM quality and stuff like that. They will be very much effective in 2025 around that time frame. In India specifically, I think we were talking to NPCI, and they were working on this secure builds and stuff like that. So I think India is also on the rise, and soon we'll be seeing, because there are AI Regulations Act that India is being part of. So we'll very soon see mandatory attestations to be added, SBOMs to be added, making the build secure, all the information being passed on. So yeah, now is the right time to get involved in these things, the core things.
That was a fantastic show until Sayam. I really appreciate you taking the time. There's one or two questions from the audience that I'd like to show. So one of the things Avinash is asking about is, what's the best way to continuously keep tabs on these and make sure that being CVE free is not a discrete one-time thing and a more continuous thing? How do we achieve
Yes,
that?
for now it's a manual thing that you have to do the BSF update, but the bot that we are working on will automatically keep checking, and then you can either say always do a BSF update, or you can notify that there is a vulnerability, and you can do a BSF update to just make it CV free. So it should work like that.
Yeah, I mean, just generally speaking, I think it's a manual process at the moment. And
Yes.
if you want alerts, you have to use a tool like BuildSafe, for example, or have something that constantly polls the vulnerability databases. And if there's, and I think the root of this goes to the stuff about S bombs that you were showing and the stuff about transparency that you were trying to build, where you know exactly what's going into a build in terms of versions, in terms of components, in terms of any open source tools that are in the build that you're trying to generate. And then you have to keep tabs on all of those things. And you can't keep tabs unless you know what's in there. You can't, know what's in there unless you use these tools for transparency. And so I think it's a bit of a big workload, a big bit of a burden for a developer to do it manually, and so using some of these tools is very convenient. And I think upstream, that's where the value of the OpenSSF projects lie, in defining the specification and things like that. And downstream, if there are people who can pick those things up and build tools like BuildSafe, I think there's a lot of value.
And
I
also
think, yeah.
the interesting thing is that the one thing to just take away from here is that, try, when you are writing the Docker files or whatever mechanism you're using for building, try using minimal, not only minimal base images, but try using minimal CVE free or minimal CVE images or CVE free images. ChainGuard has a lot of them. Build Safe will soon have a way to build those images pretty easily. And or right now you can just use without, if you just want to do without Dockerfile, then also you can use Build Safe. But there are things out there. I'm not saying that it's you have to reinvent the wheel. There are things out there that you can just use. So I think there are SBOM, like Protobomb is there. There are SBOM generation, and then there are SBOM checker. There are the vulnerability scanning tools. I think Docker Scout is a paid one, but there are free ones as well, like Trivi, Gripe. So there are a lot of things in the open source ecosystem, paid ecosystem. But the main thing is start having that mindset that, I should not use just anything out there, and let's try to see, verify, SHA and all these things, and try to use the minimal CV images before we are shipping the applications.
Cool. Yeah, thanks again, Sayam, for being on the show. I just have a couple of quick housekeeping announcements. I'll just come back to you for final comments in a minute. A lot of the things that you saw today are probably a little scary, but a lot of them are really stuff that you can tackle with some kind of education and starting to learn about security in general. There's a lot of free courses that the Linux Foundation slash OpenSSF host. You can check out this QR code right here. It'll give you some of these free courses. Some of them are introductory, some of them are slightly advanced, but they'll all give you a good baseline about how to think about security and how to get started and things like that. Um, the OpenSSF is also hosting a flagship event this year in Atlanta, Georgia. It's called the Sauce Fusion. It's in late October. It's 2 days, multiple tracks of different security areas that are going to be in exhibition. So if you're in the area, if you're interested in participating, I think the CFPs are open for 2 more days. But if you're interested in generally becoming educated about security, about policy, about security education, I highly recommend taking a look. This is a link to the Salsa project. Sayam had spoken about the project a little bit during the slides, and then shown what it means for a project to be Salsa compliant, um, and build safe, pushing people in that direction, so on. So if you're interested in exploring that project further, please take a look here. And finally, for Protobomb, which is also a project that Sayam made use of inside build safe, you can independently check out what Protobomb is, at this link. So just a bunch of different things. I'll also link these on the video at a later date, so you can come check it out. But hopefully you'll find all of these useful. Sayam, back to you. Again, thank you for being here. Closing thoughts, comments.
Yeah, I think first of all, thanks to Ram for driving this initiative, for the webinars, inviting folks, and making sure the education is being spread for the supply chain security, for various tools, practices, and all the stuff. So thanks to you, a big thanks to you on driving these initiatives and making sure everyone is kind of getting that knowledge to reach where the foundation is actually aiming to reach. For that, it needs a lot of groundwork, a lot of these things. So yeah, pleasure is all mine to be here. I hope you got a gist. So to the viewers, I hope you got a gist of what supply chain security is, SBOM, SLSA, some of the projects like Protobomb, and what BuildSafe does and helps you out. Getting involved is the only request that I do in the end. Like, these are open source initiatives, open source projects that I just talked about in today's stream. So get involved, contribute, and be part of something which is securing the world.
I think that's a fantastic message to sign off on. I 100% endorse everything you said. There's a lot of working groups who need a lot of people to help out. So if you find something you like, don't be shy to say hi and get involved with the community. All right, on that note, thanks everyone for joining us. I'll hopefully see you in a future webinar. As audience, as participants, as somebody who wants to showcase something, please reach out if you're interested. Thank you so much for watching.